Welcome to yet another video on SRID Cloud. In this topology, we're going to see something very different and interesting, I guess. I have a network on the left. They are driven by two different VLANs. They are connected to a VRF enabled core and extended to edge routers. And from there, both the networks are converged into one VRF and delivered to the customer router. Let's see how this can be done. First of all, let us look at the endpoints, the PC1 and PC2. Let me go into the so here is the PC1 and show IP. Its IP is 192.168.1.2 and its gateway is 192.168.1.1. And similarly, the other PC connected to the other VLAN is 192.168.2.2 and its gateway is 2.1. So these two different VLANs have their gateways in the core router, which we will see in a moment. But here is a switch in between, and let's look at the configuration in the switch. I think I don't have that open. Let me create one. So show IP int brief. And the first three ports 0, 1 and 2 are up and running. And if you look at the configuration, the F01 and F02 should be on VLAN 100 and 200, and F00 should be a trunk port. Let's verify that. Show run configuration, and as you can see, 00 is trunk and 01 and 02 are access ports on VLAN 100 and 200. So these two networks are isolated, they cannot talk to each other, and their gateway is in the core router, which we will see now. And that is 3.4. Here it is. Let me make it bigger. So these are the port channels and so on. So let us look at the running configuration. So first of all, I have a couple of VRFs, 1 and 2, one for VLAN 100 and 2 for VLAN 200. And look at the ports. There's a port channel 1, and it has two sub interfaces on VLAN 100 and 200. These are the two gateways for the network we just saw, 192.168.1.1 and 192.168.2.1. And here is a port channel number 2. This is for connecting upwards to the next router, and that is the edge router. And once again, it also has a port channel 100 and 200 with two different VRFs, and the same IP address is shared here, 172.16.1.2. And here is the BGP, and there are a couple of sections in it, one for each VRF. And the core router is now connected to the edge router, whose ASN is 200. So this is the neighborhood setup, and the redistribute connected will ensure the networks are distributed. So that's it for the core router. So in summary, there are two gateways for each VLAN network, 192.168.1.1 and 2.1. They are on two different VRFs, and the same VRFs exist on the other side as well to the edge router. And on the other side towards the edge router, the same IP 172.16.1.2 is used for both purposes. But on this side, the port channels carry two different IP addresses, the 192.168.1.1 and 2.1. So now let us take a look at the edge router, and that should be 32. Here it is. So these are the ports, and let us look at the running configuration. So in this router, on the right side towards the customer router, there is a VRF called customer, and on the left side connecting to the core, there are two VRFs, 1 and 2, and they are defined here. And the route targets are exported and imported from each other. So for example, the VRF definition, once route target is exported and imported into the customer VRF. Similarly for the VRF2, and the customer route target is imported into both 1 and 2 VRFs. So they kind of exchange the VRF 1 and 2. They feed their routes to the customer VRF. That's what it is. And let's look at the ports. There's a port channel 1. This is on the left side towards the core router, and both carry the same IP, 172.16.1.1, on two different VRFs. And the customer side, there is an IP 10.140.10.141 with the VRF customer on it, and that is it. And then here is the BGP, one for each VRF. So the customer, the neighborhood is the customer router IP address 10.140.10.129, and the VRF 1 and 2, their remote their neighbors are the edge routers, or I should say core routers, 172.16.1.2 on two different VRFs. So that's it for the edge router. And now let us look at the customer router. So these are the ports. There's only one port in use here anyway. Look at the running configuration. There are no VRFs or anything like that here. Let me check again. Nothing. And there's only one port on this one, and there should be a BGP on it as well. So the Gigabit Ethernet 1, that is what is connected to the edge router, and its IP is set to 10.140.10.129. No VRFs or anything like that here. And here is the very simple BGP, and no VRF, and it is on the global address table. The neighbor is 10.140.10.141 on the edge router, and redistribute connected will ensure this network is kind of distributed. So this is it. And now let's look at the goal. Let us go to the PC1 and then try to ping 10.140.10.129 all the way to the customer router. We'll look for the PC1. And I'm going to ping 10.140.10.129, and it's working good. And then I'm going to go to the second PC, which is on VLAN 200, and try to ping the same IP, 10.140.10.129. It is working okay. So now before we close, let's look at the routes in each of these routers. Let's go to the core router first, which is 3.4. Show IP route. There's nothing in the global address table. We have two VRFs here, and let us look at the address table, routing table for both the VRFs. Show IP route VRF 1, and it has the 10.140.10.0 network coming all the way from the customer into it. That is what is BGP all the way here, and everything else is kind of connected directly. And now let us look at the second VRF. There is 2, and it has something similar. The 10.140.10.0 is BGP all the way to this router, the core router, via BGP. And now let us look at the routing table of the edge router, which is 3.2. So here there are 3 VRFs, and let us look at their address tables one by one. This is the router where the route targets are exported and imported from 1 and 2 into customer, and then the other way around as well. So show VRF, show IP route, nothing in the global address table. Show IP route VRF1, and here also the 10.140.10.0 got imported BGP wise all the way from the customer network, and the 192.168.1.0 network got BGP'd into this router, into this edge router via the core router. So this is the bridge between, this router acts like a bridge between the VLAN 100 network 192.168.1.0 all the way to the 10.140.10.0 network. Similarly, for the other VRF, same thing. Here 192.168.2.0 got imported from the VLAN 200 network through the core core router, and the 10.140.10.0 got BGP'd from the customer router. And now finally let's look at the routing table of the customer. And there is no VRF or anything like that here, so show VRF shouldn't show nothing, and show IP route shows quite a lot of things here. So first of all, the 10.140.10.0 network is directly connected to the customer router, so nothing interesting there. This 172.16.1.0 network got imported. That is the network between the core and edge routers, and that is imported into the customer router. And also both the VLAN networks 192.168.1.0 and 2.0 also got imported into the customer router. So in summary, this is how you implement the separation of the network on one side and converge them into the other side. So there is a reason why I have core and edge routers. You can replace them with only one router for this topology and for the purpose of this video anyway. But my intention here is to keep a separate environment called core environment, where I have multiple VLAN networks, the isolated networks, 192.168.1.0 on VLAN 100, 192.168.2.0 on VLAN 200, and they are served by the core router from the gateway perspective, and 2 different port channels and 2 different VRFs as well. So there's a separation of the network VLAN wise on the level 2 and VRFs on the level 3 point of view. And I extended the same separation between core router and then edge router as well. So on the core router we have 2 port channels on the left side for each of these VLAN networks. Similarly, there are 2 port channels on the right towards edge router, and they keep the same VLAN ID in the sub interfaces. And on the edge router, on the left I have the 2 VRFs. These 2 networks are separated, but on the right side I have only one VRF, that is customer VRF, where these 2 routes from VRF1 and VRF2 are fed into the routing table of the customer VRF. So if a customer wants to keep the network separate, they can do so at the endpoint level, but they can access both of them from a centralized location, that is the customer router. So any switch and any endpoint can be connected to the customer router, and they can access both the VLAN 100 and VLAN 200 networks. Whereas the VLAN 100 endpoint and VLAN 200 endpoint, they cannot talk to each other. They can kind of keep themselves separate. So I hope you enjoyed this video, and probably some of you learned how to do the export and import of route targets to feed routes from one VRF to the other VRF, and also at the same time how to implement VLANs and port channels and VRFs and so on. So I will produce a lot more videos in near future on various other topics. Until then, bye for now. Bye for now.